A pre-purchase inspection of any vehicle is critical for determining the quality of the vehicle and whether any major or minor repairs will be necessary in order for the vehicle to remain in good service. Performing an inspection on an electric vehicle is very similar to inspecting an internal combustion engine with a few additional steps. Research has shown that consumers have many of the same concerns when buying an EV as they do when buying an ICE vehicle. This is particularly true for first-time EV buyers. EVs are equipped with some components, such as the high-voltage batteries and charging units, which require specialized equipment and expertise to properly diagnose and repair. Only a qualified technician should perform repairs or maintenance on these components. However, EVs do also have many of the standard components found on ICE vehicles, such as the suspension and lighting systems. While the technician performing the inspection is not required to be a specialized EV repair technician, they should have a basic understanding through training. EV training and certification like EVfriendly is ideal. The technician must understand and apply critical importance to the high-voltage systems. Other items, like the HVAC, for example, will be very similar to their ICE counterparts, but in an EV, there are unique differences that set it apart and will require the technician to be well versed with this technology to identify potential problems during the vehicle inspection. About the inspection guidebook. The EV-friendly inspection guidebook was designed for dealers looking to conduct pre-sales inspections for their inventory or for customers who are looking to purchase a used EV and are looking for some assurances that the vehicle they are considering is a good investment. While a pre-purchase inspection cannot tell you everything about the vehicle, it can, if performed by a qualified technician, give some indication of the vehicle's overall condition and what, if any, repairs will be required. It is an important tool in helping you determine whether the EV you are considering is right for you. The following are specific areas the technician needs to scrutinize when performing an EV inspection. Vehicle Systems Scan Report. Performing a system scan of the entire vehicle is always a good idea regardless of whether it is an EV or an ICE vehicle. But on an EV, the codes may reveal an issue with the charger or the HV battery. It is not uncommon to find erroneous codes stored in an EV that have no related problems to be concerned about. This is where experience in code diagnostics is an asset, but recording and providing codes in the inspection report is also a good practice. Most aftermarket scan tools will allow the technician to attach a digital copy of the system scan to the report. The importance of quality checks of high-voltage batteries. Research has shown that for new or potential new owners of EVs, the biggest concern is the quality and/or degradation of the vehicle's high-voltage battery. There are a few items the technician needs to record before they can make a true evaluation of the HV battery. It requires specialized scan tools and training to be able to determine the health of the HV battery. In some cases, the information can be hard to find and may require vehicle-specific scan tools. However, some information is easily available, often right on the driver's vehicle information display. State of health. State of health, or SOH, is the ultimate indicator of a battery's degradation from the factory output. Some manufacturers' batteries are known to degrade faster than what is considered to be normal, which makes it even more critical to determine the quality of the used battery. State of health can sometimes be displayed on the driver's information display panel. For example, the driver screen on a Nissan Leaf displays a 12-bar gauge indicating state of health, a simple and easy way to identify the battery's health. State of health can often be displayed in the Battery Energy Control Module, or BECM, using a scan tool. A vehicle-specific scan tool is often required to retrieve the state of health information, but it can also be found using a generic scan tool that utilizes OEM functionality. The information will not be found using an OBD2 code reader. State of health is displayed as a percentage and does not exactly correspond with the information center's bar graph gauge, or the predicted vehicle range. Obviously, if the reading is closer to 100%, it means the quality of the battery is excellent, but batteries at 80% or possibly even lower may still be usable for drivers who do not require the full range of the new battery. Predicted Vehicle Range, or PVR. PVR is a way to determine the state of health when the technician has no access to the required scan tool. The PVR is displayed on the driver's information center in kilometers or miles. The PVR is an estimated vehicle driving distance based on the previous driving habits of the last drive cycle. A fully charged battery's PVR can be compared to the factory's recorded expected range, and from that, a theoretical state of health of the battery can be determined. State of health is not a linear representation of the PVR, and PVR will not behave the same from vehicle to vehicle. If the manufacturer's rating is 130 kilometers and the PVR displays a 100 kilometer range after a charge, the technician would know that a significant amount of degradation has occurred. PVR is most useful for a fully charged battery, so inspecting the vehicle fully charged is ideal. Recording the PVR on the inspection is advisable. State of charge, or SOC. The state of charge is the indicator of the level of energy an HV battery has stored compared to its capacity. The state of charge can be displayed on the driver's information display as a percentage or a level gauge. State of charge can also be recorded via a scan tool through the BECM data list near where you would find the state of health. Recording this on the inspection is recommended. Vehicle charging systems. One of the most common failure points on an EV is its ability to charge the HV battery. It can often be the case that the fast charging ability operates normally, but the vehicle fails to charge with the EVSE. During the inspection, it is the technician's responsibility to test these systems to the best of their ability. The technician should start the charging system inspection by first locating the vehicle's EVSE and performing a visual inspection of the plug. Often, the 110-volt connection is partially melted and may require repair. The charger port should also be visually inspected for debris, bent pins, or a missing charge port cover. Plug the customer's EVSE into the wall outlet and to the vehicle. Most EVs have an LED indicator to display to the user that the vehicle is being charged. LEDs typically flash slowly and can indicate the current state of the charge with a simple LED bar graph. Vehicles that exhibit charging issues often will have the LED flash in a way to indicate an error, or the LEDs will simply not illuminate, indicating there is no charge occurring. Shops that regularly service EVs should have a Level 2 220-volt charging capability, as it is recommended that the Level 2 charging be performed as well as the Level 1. Some vehicles will also be equipped with DC fast charging. However, it may not be possible for a technician to perform testing of this feature due to the location of the nearest charging station, but the technician can advise on the inspection that this feature has not been tested. It is recommended that the technician use all three versions of charging when performing an inspection on an EV. A vehicle may show no indication of issues until the function is attempted. Codes may only set when cleared before the inspection, and these functions are then initiated. Heating and air conditioning. Electric vehicles have very similar HVAC components to their ICE counterpart vehicles, but are typically more complicated because of their use of high voltage and other unique components. Repairs to these systems can be very costly, so simple checks can go a long way towards prevention. Checking these systems is also important because they are responsible for cooling the high voltage systems on the vehicle as well as the cabin temperature. During an inspection, the technician needs to simply identify whether a problem exists, not necessarily what the root cause of the issue is. Performing a simple HVAC performance check while road testing can point out areas that require further diagnosis. Simple visual checks of coolant levels, hoses, and signs of leaks can reveal potential costly repairs and/or items that may require further inspection. Low voltage systems. EV low voltage systems are often overlooked, but can be a cause for major issues when it comes to getting a vehicle into ready mode. Technicians should make every effort to perform a low-voltage battery performance test with the appropriate tool, as well as estimate the battery's age. Checking the low-voltage battery can also reveal issues with the DC to DC charging system. EV component inspections. EV system failures typically identify themselves to the technician through warning lights and messages, but visual inspections of the components may indicate future problems that are unknown to the vehicle owner. It is recommended that technicians inspect high-voltage cables for signs of physical damage such as rubbing through or rodent damage. Visually inspecting for coolant leaks from the drive motor, the inverter, or the high-voltage battery is also recommended. The oil level and condition of the drive motor's final drive unit can also reveal potential issues like bearing wear. Physical damage to the undercarriage shields and the high-voltage battery case should also be recorded. Tires, brakes, and suspension. EV tires are often overlooked by the consumer. Proper rating, tire pressure, and tread wear must be recorded. EV regenerative braking systems are utilized less often, but because of this, they may require servicing before the pads are worn out to ensure they are working properly. When inspecting an EV's brakes, refer to the vehicle's maintenance schedule for brake servicing. EV suspensions will be identical to their ICE vehicle counterparts, but noises may become prevalent upon further inspection. It is recommended that technicians record any suspension noises during the inspection. Advanced Driver Assistance Systems, or ADAS. In the future, it will become standard for every vehicle to be fully electric. Vehicles will also become increasingly automated. Technicians should check the function of each system on the vehicle to make sure they are functioning normally. During a road test, the technician should test the lane keep assist, departure warning, adaptive cruise control, parking aids, blind spot and cross-traffic alert systems, the backup camera, and surround view camera. As you would with any vehicle, when you first bring it into the shop, begin by having a second person check that the lights and signals are working properly. Check the windshield wipers and washers. Check the driver's information display and note the current predicted vehicle range and state of charge. Note any system warning lights that may be illuminated. Check the HVAC system. Raise and lower the temperature and operate the fan settings to make sure that there is sufficient airflow and that the system is heating and cooling properly.
Check the horn.
Under the hood, remove the protective cover to gain access to the components beneath. Test the vehicle's 12-volt system. Check the CCA rating of the battery. Connect an electrical system analyzer to determine the current state of health of the 12-volt system. Check the fluid levels, such as brake fluid and coolant. Some EVs may have multiple coolant reservoirs. Inspect the orange high-voltage cables for damage, such as a rat chewing through them. Note that if there is any damage to these cables, you cannot just splice in a new section. You must replace the entire harness with either a new one purchased through the dealer or a used one from an auto recycler. Inspect the cooling system hoses for signs of leakage. Inspect the air conditioning components like the compressor and pipes for signs of leaks. Inspect the radiator. Inspect the charging port first by making sure that the access door opens and closes properly, and then check the pins for any signs of corrosion, bent pins, or water intrusion. Connect the EVSE to the wall socket and then to the vehicle's charge port. Connect a scan tool and perform a complete vehicle scan, all modules, and record any codes found. Now you're ready to lift the vehicle to perform the under-vehicle inspection. Refer to the vehicle manufacturer's information for the proper lift points. Check the axle and drive unit for any signs of oil leaks. Check for coolant leaks. Checking the cooling system components and hoses from underneath may reveal leaks that you did not see when inspecting from under the hood. Remove the drive unit fill plug to inspect the oil. A small drop should come out, indicating that it is level with the bottom of the hole, and make sure the oil looks clean. Removing the underside cover plates will expose more orange cables that you may wish to inspect. Inspect the battery case cover for signs of damage such as dents, scrapes, or leaks, which may indicate potential damage to the battery itself. Inspect all the electrical connections to make sure there are no signs of abrasion, rub-throughs, or rat infestations. Also check here for any signs of coolant leakage. Check all of the CV boots, the sway bar end links, and visually inspect the struts for any signs of leaks. While underneath the vehicle, you may have a better view of the AC condenser. It is very important to inspect this for damage because in some EVs, the AC system also cools the HV battery. Here's an example of where the bellows on the strut has deteriorated. Rock the front wheels to check for any excessive play in the front end suspension. Give the wheels a spin to make sure the brake calipers are not sticking on. Remove the wheels to perform an inspection of the brakes. Measure the thickness of the brake pads and record it on the inspection sheet. Check the tire pressures and note the readings, and then adjust as per manufacturer's specifications. Check and record the tire tread depth. As you have seen, performing an inspection on an electric vehicle is much the same as performing an inspection on an internal combustion engine vehicle, with a few notable exceptions.